All right, sir. Thank you very much, sir.
So this is
Thank
the
you.
question itself. Let me just open the question. So it's actually a PDF question. So this question. So in case you might want to download it. So let me just download my desktop. So still okay, sorry. And this is the data set. So let me open the data sets. Some of you might be struggling to open data sets. All you need to do, you have to just click on Ctrl S or Command and S. Okay, it's not saving that way. We can also do it this way. Let me open. I'm going to open with spreadsheets. So the data is going to open with spreadsheets now. Because you might be having some issue trying to download the data. Data has already been uploaded on the platform already. So it's still coming up. While it's coming up, so this is the question. Let me also open the question by my own side as well. So you all know we have different platforms actually running this thing. Some of you might be using Jupyter Lab or Google Colab. For me, I'll be using Jupyter Notebook for this explanation or this tutorial for tonight. So just launch your command line. When you launch, it's still loading, maybe because the data is quite much. That's the reason. But it's going to come up. It's going to come up. Though I've downloaded the data already. This is the data. I have it. So let me just see download it again. Now, all we need to do, I'm going to launch my Jupyter Notebook. So while it's coming up, so this is my Jupyter Notebook. So let me just go to my desktop. I'm going to create a new folder. I'll just create a new folder. In this folder, let me just basically give it a name. Let's call it as final exam. So I'm going to open that final exam. This one is still taking time to come up. So I actually have the data somewhere.
Please, when your screen is up, if you can increase your font, it will be nice.
My words.
If a font size of the right of board, you can zoom it.
I think that's the maximum it can do. Why the data is, I've already downloaded the data set already, but it's just waiting time. But I have data set already. This is the data set. Housing data dots. It's an Excel file. So we have the data here already. So you can see we have the housing here. We have the housing here. So we can use Excel to actually do this data. And this is the first column. Or you can also convert this data into a CSV file. Some can just go to maybe like file, then you can now save as. And because we want to save this particular page alone, I just change to maybe CSV. This CSV, comma separated rather. So it's going to save this particular page alone. You can just save it as. So it's still the same. That means only this part, because this is the part we need. We don't actually need this part. This is the description. This is my actually, though I can use Python as well to actually read only this particular line, but just to make it easier. So you can see I have the data in form of CSV as well again. So that I can still open the same data. Can you now see for one example? This is still to minimize it. Let me just upload the data here. I'm going to click on upload. Then I have this. Then I also have housing of service. So let me just upload it soon. I have the two uploaded on my own something. So I'm going to create a new Jupyter notebook. So click on file, new Python 3. So we have some questions that actually require writing. It asks us to explain what ED is all about and what does explorative data analysis all about. I think that's what it's all about. So this one here, it's more of like we'll be writing, talking about the importance of EDA. Like it helps us understand the data we are dealing with. It also helps us to understand some of the statistical information about our data. And in fact, most of this EDA always come in form of charts, in form of table, in form of that basically. So we'll just explain it. So the main part I'll be talking about is this, how to build this machine learning, which I think is the technical aspects of it. So the question says machine learning model building. Choose a suitable machine learning algorithm for predicting housing price and train a simple machine learning to predict housing prices. So what I just telling you is that we have this data already. This data in form of CSV or Excel. That means this is the data. We are trying to predict the housing price. Okay, essentially is the what we're actually predicting. This last one here, MEDV. Yeah, that's what we're actually predicting from the data sets we have there. This is the pricing. I think the last console is the pricing. Might be because of the name. So how are we now going to understand this data to predict this outcome? So first and foremost, we need to import some libraries. So this is just general machine learning workflow. You need to import the library. When you import the library, then you import the data set. So I'll be importing some necessary tools like pandas as PD. So let me import pandas first. As we keep moving, I'll import some other necessary thing I think I need to import as well. So, okay, I think we also talk about doing some EDA at the beginning also. Okay, perform expected data analysis on the target variable, housing price using box plots. Okay, so let's also do this part as well. So yeah, we have to do some EDA. So let me just copy the question. So we have to perform. So let me input data. So let me just call PD dots. We have CSV and also have Excel files also. So we have the housing. That's the name of the file. Yeah, that's the name of the file. So we have, okay, it's actually capital letter housing. So this is what I'm going to use. So I'm going to store it in a variable. Let's just call it maybe in house. So I'm going to run it. So I'm going to call my house, or maybe the head office. So this is the data that we're actually working with now. This data we're working with. Now, the first one, perform expect data analysis on the target variable, housing price. This is the target variable. This is what is the dependent variable. That's our Y. No, and other relevant features like histogram, scatter plot, and box plot. Now, you are just asked to do some distribution. That is the histogram. Now, if I want to do anything in form of visualization, we have a library called matplotlib. Though you can even use pandas soon to actually do some EDA soon. You can use pandas as well, but it's very nice when you use the matplotlib. So I can just say import matplotlib, then the spy plots as TLSim. So we have this matplotlib. Let's really do some EDA. Okay. I can just look at the EDA based on the age. What I need to do is that I'm going to look at my data. This is my data, so I can just say my housing. Then I'm going to pick that particular age, particular column I'm working with, that's the age. Then I can just say dot text, yeah. So we can do something like that. I'm just using the pandas we actually visualize this pandas. I'm using panda because I use pandas to read data. Then I'm just checking the distribution of the age. So basically, it's basically this data actually combined of those about 80 to 100 years of age. Then we have that very low. That's one plot dimension. Now, if you want to do another thing as well, all you just need to do, just need to replace this age with anything because we have the value here. Then if you want to use this same, I don't really know what this means, but these are the features that we have there. We can replace it with anything we can talk about. Then also we can also use PLT dot east as well to east. So that same age there too. I'm just going to call my age. So when I run this value, it's going to give us something like this. Okay, PLT dot east. So let's just stick with the pandas way, but there are different ways of actually doing this thing. So we have scatter plots. Now, when they're talking about scatter plot basically means that you're trying to compare two things together. Maybe trying to plot, maybe you can just choose any features you can think of. For example, I can say I want to plot the LSTA and the median and the target. This is the target. So if I want to do that, I'll just look at. So this is what I need to do. If I don't really know, I can just call my house, then those columns. It's going to give me the column names. So I can just say PLT dot scatter plots. As long as I call my scatter. Now I know my scatter will always have X and Y. It will always take in X and it will always take our Y as well. So I can just say, let's my X be. So now there are different ways of actually running this thing. I'm not going to make mistakes. I'm just going to copy this LSTA, then comma, then my Y. My Y is my words, MEDV. You can see, I can't run like this. I must actually provide where this thing is actually coming from, my data, which is what's the house. So when you run it, you're going to have what's a scatter plot. So you can see all this thing coming out. Some people usually put this semicolon just to stop that thing from not showing. So this another but I also mentioned. So that means I can actually also plot this one as well. So let me just copy the whole of what I'm having here. I can paste it here, then change just anything. I can just say ahen indoors. I don't know what it means. So I can just replace it and run it again as well. So you can see. That's I can just keep plotting. You can also we have different means of actually plotting this as well. So this you have different means, but this is just the best way you can use this using matplotlib. Why for this histogram I use what pandas to plot it, which is still work fine. Now next one we also have there is box plots. Box plot is basically used for checking outliers in your data. That's what box plot basically used for. Now we'll look at um the blood spot, or maybe I just take any of the variables as well, so any of the features that we're mapping there. So how do I plot my box plots? All I need to do, I'll still use the same matplotlib PLC dots. I'll just call my box plots on it. Box plot also takes, you can see, it just takes only X variable because you're only checking the outlier on a particular feature. I said I want to check it on this now. So I'll just look at my X variable. What's my X now? My X is actually this. Then where is the data coming from? Data is still coming from us, my house. That's a variable. When I run it, it's going to give me, I'm not having anything there. So let me just change. Okay, I can have something there. But let me just provide this. I think another variable I can actually apply on this. I'll make it like that. Since, okay. Let me change the value. So maybe something like this. Yeah, these are my box plots. So you can see we have uh, outlier. Okay, I think value are above this range. Actually, some of the outliers in the data sets. So they didn't ask us to move anything like outlier. They just only asked us to show some of the outlier in the data sets as well. So that's what they asked us to do. Now what else? You can check outline on each and every of the features, each and every of the features that we have there. Each and every one of them. You can check it based on this, based on that. All you just need to do, you just need to replace the name. Then this one actually requires two targets, two features, I mean. Then for this one, for the last one, which is just need to just change it to any of the features. So that's that about that. Now moving on to the main question for today. Let's go back to the question. So based on the EDA, now we have to discuss some of the insights from the data sets. All we just need to do, we just need to understand how these charts actually looks like. Oh, what are the features? Does LHC have effects on this? If you look at it, we have more of like um negative, we're not really moving the positive part, it's actually moving the from the left hand side downward. That means thing is going down. That's the trend I can see here. So we can actually compare. They didn't ask us to stick to one particular features alone. So since everybody can do each can just pick on any features, what actually caught your what are your interests? Do you want to check this on this or the tax on MB and MEDV? Can you can write a report on it? Now you can see this value now. For example, this one actually has a lot of outlier from here. This is where the data actually is. Then there are some outlier above and then some just I think a point actually below it as well. So we can check for other features as well soon. Now we have our data set here, housing, then it's about 506 rows. So this data, let me first and foremost check if there are missing values there. So because in machine learning, we have to check if there are some missing values there. So this one basically telling me that there are actually some missing values in the data. Like CRIM, we have 20 missing values here. ZN, we have 20 missing values. We have a lot of missing values. YNOR, we have 0. RMN, we have 0. All of that means this 0 indicates that there are no missing values here. Then our housing price, what we're actually predicting does not have any missing value. That means we have to take care of this one with 20, 20, 20 values. And we have to look for where we're actually clearing this. Now, depending on how we look at the question at hand, there are three different ways we actually use to fill this missing value. Some people will tell you that, oh, it's better we just remove the missing values out of it. Mind you, if you remove the missing value from here, does not mean if you remove 20 here, 20 here, 20, 20 here, alas 20, 40, 60, 80, almost 100 from 500, that means we are going to lose a lot of values, a lot of values. Why some will tell that, oh, let's fill it was with the median. Some will say, let's fill it with the mean. Some will just decide the value by themselves. I say, well, since it's just, yeah, based on their own domain knowledge, they can decide to fill it with something. That's okay. Oh. Whenever we are having missing value, why don't just see, we should just fill it with just -4 or 5 or 2.5. Just anything they can think of. It's based on their expertise in the field. Now, for this one here, we are not actually what me I use is the median here. The reason I use the median is because I look at the data itself, then I was able to now let's look at this CRF and look at the median itself. If I look at this, if I look at the housing itself, so I mean I want to pick the value of each and every one of them. For example, so sorry, we have 3 point this, then the average of this, see, from let me just import numbers and NP dot average of this is the mean is still average now. What am I saying? The median. So that's The median is 0.2. Now, what about let's look at what the max. The max value of that is, then the minimum value was that will be 0. Now it's 0.00000. Now you can see we've checked different statistical, or how do I put this, some different means by which we usually fill the missing value. There's a series of tests people always check to actually fill those missing values. Some will go with the mean based on some particular their own level of understanding. Some will go with the median. Some will go with the frequency, the one that appear most. Some will go with it as well. So we have different ways. But in this class, let's just decide to do those with the median. Let's fill everything up with the median. So that will be then. I'll be filling all the missing value here with the median. Like I said, this one is actually left to us. It's not that maybe we have one it's a just compulsory, we have to know. It's not going to have to fill with median. It's left so can some decide to fill with the mean. While some with their own level of expertise, they can tell, oh, why don't you think we should fill it up with so value? So value. So I'm filling up with the median. All I need to do here is that I'm going to look at all the value I'm having there. So let's look at my housing. Then let's call the features there. I think we have so let me just call it from there. We have the housing. So let me just start calling it. Look at where the one I'll be calling. I'll just only call the one that have missing values. ZN. Then I also keep the answer. Now I have to just do it here manual. I'm not There are ways I can actually fill everything up together. Yes, I just want to do how we can understand this better. Because if I just call fill hand here on everything, it's going to fill everything up. But let me just simplify it in the words. Maybe where we can understand what we are doing. We have the H, then we have this one as well, too, as the last one. I think that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is the ones with missing. All I need to do, let's call my fill hand here. So while I'm against, no, filling is not, I'm coming. Some days we will always call it, I don't want to feel it manually. Actually, if we always feel it, so I want to fill everything together at once. I'm not using, okay. Just looking for the best method of actually filling this thing. Okay, let's do this one. If I call my house dot fill hand here, should I just use pd dot fill hand here? Okay.
Hello, below. Hello. Hello, house.
Hello.
Hello, everybody.
Hello.
Please, we're having about less than 10 minutes before this time we lapse. So when it lapse, please, I would like you to come back again with the same link. So everything is being recorded.
Okay.
Right.
So this is the main. Okay. So all I need to do is I'm just going to call my house dot fill hand here. Now, so I'm just going to call this same main on it. So it's going to fill everything. So yeah. So let's use main. We can use it, and I said also we can also use median as well. So it's not really there is one particular law that actually tell us to use one particular instance or not. It just depends on how you are trying to solve it. We ourselves, we can try different means. If I say, okay, after filling with me and I apply my model did not work fine. I can try to change it. I can say maybe because I use the mean. Why don't I use the have maybe like the minimum or the maximum or another instance as well? So also part of some of the things we check. So let's just use mean. So I use mean now. Now because this thing is not yeah, okay, this is so let me just see call it. You can just reassign it back to that. So I'll just call my A, then the sum. So you can see we're no longer having any missing value there again. Everything has already been filled up. So the next step we need to use here now is now actually our house, and there's no any missing value there. Everything is I just check again that is NA, then maybe that's sum, or you can even some people need to use the mean as well. So just to see, you can see we don't have any missing value. Now, the next thing is to do, you have to look at, we're actually separating our X and Y. So from up down to this, second to the last is our X. That's our independent variable. Then this our MEDV is our dependent variable. This one is actually dependent on this. So let me just quickly create a subset for that. So I'll just say my X is actually, then for me to actually, I have to look for actually cutting this one off. Some use those maybe I lock or lock is still fine zone. But I always prefer the drop method. I think that is the one of the best approach. But even the one used in most of the tutorials is drop. So we'll just call my house does the drop. What am I dropping? I actually want to drop this one. I have to paste it here. Then comma is on what axis? As that as one. That's on. So if I look at my X dot A now, can you see I've dropped it? That's MEDV is no longer there again. So it has removed. So for my Y now, what's my Y? My Y will be my dependent variable is yeah, that's the form of series. So that's the MED, sorry, that's house, then M, sorry. So this one is it's definitely be in form of series. Because actually was one particular answer. It's actually a series. So this one is actually depending on this X. It's based on the characteristics that will determine this price. That will determine the price. So at this point, are we all clear? So moving ahead. Now the next thing we need to do here is actually looking for we're actually dividing our data into 4 different subsets. Our training, our S train, S tests, Y train, Y test. Now let me look at this data we have here now. We have about 500 plus data. This one here is actually our Y. So this is our Y. The remaining one here from here to this part function here, or to this part. It's actually maybe our just use another different column. Is our X. Now out of this X now, we have to look for a way of actually cutting it from maybe here. That the best way. I'm also cute. Let me just use, you can see I have one portion here. I have another portion here. I have another portion here as well. So I also have another portion. That's 4 different subsets. So I will need to train my data, my model on this portion here. Then I will evaluate the performance of my model on this my Y. So that's all what we are trying to do. We are trying to divide that into 4 different subsets. So there is actually how will I call it, a method that we always use is the train test place. So all I need to do, I'll just say from scaling dot model selection. So let's selection, then I have to import my train test place. So when I import my train test place, so what train test is all about is just basically helping us to divide it into 4 different subsets. Now, I'm not saying we can actually cut this thing into 4 if you by using our high lock, panel high lock, but it's not really. It will still work. It will still work. That means we don't want to go with this package. It will still work. But we always prefer this one because of the randomize. The idea is always randomize the value for you. That means not going to just put one particular set of data in one portion. All right, so randomly pick them. So it's going to take every aspect of it. So it will be very, very difficult for the model to actually understand the data. And at the same time, it will be prone towards overfitting. Because we have to look at actually training the model. So it's going to understand the data very, very well. Not just learning, it should be able to perform on the data that it has not seen before. So I've imported my train test case. All I need to do, I have to call my S train. I have to call my S train, train, comma, S test. Then Y train, comma, then Y underscore test. So then I'll call my method train test please. Then I'll specify my X, comma Y. This is my X that I had earlier. I think this thing is about to stop. It's about to stop. It's asking less than a minute more. So as soon as it stops, so let's just reconnect back. So
Okay,
we
so
have
less than 1 minute now. So let it stop. When it stops, then you can now connect back. So hold on. I think it will wipe away now, so we can start again.